Okay, so I wish I could give credit to who I stole this from, but I don't remember the teacher's name anymore. So if you're listening, teacher, I'm sorry. So laws of exponents, right? So like I said, we've already covered all these previously in other math classes, so we're just kind of putting them all together. So this is your first one. And real quick, before we get going, when I give you something like this, how many people in here just copy down everything verbatim? Okay, that's a really long way of taking notes. Okay, one of the keys to note-taking is being able to weed through what they give you and get down to what you need. So, where should your eyes look first?
The red.
Okay, either the red or to the box, right? So, do you remember seeing this before?
Kind of.
Kind of? Okay, if you're at kind of, then you should probably grab this section right here, right? Product of powers. For any real number, a and all positive integers, m and n, then a to the m times a to the n equals a to the m plus n. So it's the definition of it in English. You get the symbolic representation in math, and then what else do you think you might want to include? One of the examples, right? So either grab one of these or one of these. Do you need everything, though? No. Now, if you're looking at this and your brain goes, oh, yeah, I remember this, then what part do you really need? You really just need what's in the box here. Okay? So that's one of the joys of learning how to take notes is what information does your brain need? Okay? So what I'm going to tell you is if you look at it and your brain's like, oh, yeah, I know this. Not I think I know this, but yeah, I know this through and through. Then just write down the important piece, right? If you look at it and your brain's like, I kind of remember seeing something like this, then if that's what it remembers now when it's focusing, later it's going to remember less. So you need to include what we're talking about and then probably an example so your brain can reference it later. Okay? Everybody good? Yes, no, maybe. So like you've already talked about or should have talked about in your middle school years, when you have same bases, and this is actually the key here, is that you have the same base. Okay? So when it comes to exponentials, an exponential equation has two parts. Okay? So like what does an exponent look like? How would you write an exponential statement? Just say what your brain's thinking because you're going to be mostly right. Okay, 4 squared. So if you notice it has two pieces, right? So what do we call this piece? This is the base. It's, no, yeah. Just in general, whenever you see an exponent, it has two pieces. It has a base, which is the number that's being taken to the exponent, and then it'll actually have the exponent here. Okay, a little bit of language real quick. Some of you have a habit when you see exponents to go like, if it's x to the 5th, you'll say x5. In math, if you use a variable followed by a number, like x5, that actually means that, x sub 5, okay? And is subscript the same thing as superscript? No, x5 means that it's the 5th x in our set of equations. Okay, just like we use y sub 1, y sub 2, right? So, when you mean exponent, you have to actually use the phrase to the. That intro tells the reader that the next thing that comes out is actually going to be an exponent and needs to be written as superscript. Okay, so please be careful with the language because I have a tendency to write what you say and I'll be writing the wrong stuff. Okay? So, if you notice up here, it says that if they have the same base. So, what we're looking for is like in our example here, 4. Or if you look at the box, what's the base here? And what's the base here? A. So if they have the same base, we write it as a single base, and we just add the powers. Okay? Now where that actually comes from is if you take a look at this example, we have 3 cubed times 3 to the 4th. So what does it mean to cube something? Multiply it by itself 3 times. So 3 to the 3rd is 3 times 3 times 3, right? So what's 3 to the 4th? 3 times 3 times 3 times 3, right? And we're multiplying. So exponents are just repeated multiplication, kind of like multiplication is repeated addition, okay? So if you count, how many 3s do I have here now? 7. So instead of writing it 3 times 3 times 3 times 3 times 3 times 3 times 3, I can just write it as 3 to the 7th power because I have repeated multiplication. So all we're really doing with these laws is finding a shorter, quicker way of writing the exact same statement. Everybody okay with that? Yes, no, maybe? So everything you're going to see is kind of going back to if we did it by hand, there's a longer version. But if it always works out, why keep doing it by hand the long way if you can find a shortcut? That is always true. All right, so let's hop to some examples. Yeah, it's what we're really looking at is simplification. So when you simplify, you're going to add the powers, yeah. So if you look here, yeah, so if you take a look, right, for number 1, do we have the same base? What is the base? N. So if we have n to the 5th times the n to the 3rd, we keep the base, which is n, and then what do we do with the powers? So what's 5 plus 3? And you're done, if you need it. Remember, notes are more or less for you. Like, I don't have a minimum expectation on notes. That's why I don't print off notes for you guys, is I can figure out what I think is important, but you might look at it and be like, yeah, that doesn't help, okay? So for your notes, you need to, whatever you think your brain needs to help it make sense and trigger the correct response is what you need to be writing down. When you have the same base multiplied, you add the powers. So we took 5 plus 3 and got 8. So for number 2, what's the base? K. So I have a K and a K. So my base stays as K. And then what do I do with the powers? I add them. So what's the power here? And the power here? So what do I get? Right. So because like K to the 4th means K times K times K times K. And then we have a K to the 1st, we have another K, right? So how many total Ks do we have? So that's why it's K to the 5th. Okay, so it's kind of weird because when we multiply, we add the powers. But the reason is because we're repeating the multiplication. So we're just going to be adding this number of Ks to this number of Ks. We do it the same way. Mm-hmm. Yeah, so like if it was 2 to the 5th times 2 to the 3rd, we would get 2 to the 8th. But then we can calculate 2 to the 8th, right? So if you had to evaluate this, which one would be faster? 2 to the 5th times 2 to the 3rd or 2 to the 8th? 2 to the 8th, it's just one calculation. Okay? So, for number 3, what's the base that's in common? Y. So my base is Y. And what do we do with the powers? So what do we get? 12. All right, for number 4, any ideas? What? Okay. Why? Wait, can I just do that? Well, that's for the A's. 2 and 4 don't have the same base. I mean, technically they do if you converted 4 into 2 squared, but you're right, but I want to know why. Does order matter in multiplication? Does order matter in multiplication? That's why you can do it. Okay? Order doesn't matter here, and this means 2 times a cubed, right? So what I'm going to try to get at here is whenever we simplify, whether it's multiplication, addition, or whatever, whenever we simplify rational expressions, or, sorry, exponential expressions, we always want to group things by base. So if you look here, I have 4 distinct items. I have a 2, I have an a cubed, I have a 4, and I have an a squared, right? So which of those have the same base? The a's, right? So I'm going to put a cubed with a squared, and they're being multiplied, right? Now, order within multiplication doesn't matter, so what's left over? So I've got this used and this used, so what's left? The 2 and the 4, and what's the operator between them? Multiplication, so I'm taking 2 times 4. So that's what I was trying to get to. So what's 2 times 4? 8. 8 to the 5th, perfect. Okay? So you multiply the things without powers together, and then you use your regular property for the bases. So if they have the same base, we can add the powers on those bases. So a cubed times a squared becomes a to the 3 plus 2, or a to the 5th. Everybody okay with this property? Yes, no, maybe? All right, do you remember doing this stuff? Okay, sweet. Yeah, it's probably been a minute. Hey, that one actually kept the zoom. So here's the next one. So the first property that we had was same bases being multiplied together, and then we wound up adding the powers. Now in this situation, I have an exponential equation being raised to a power. So I have the power of a power. And what does the property say I do? If I have a power of a power, what do I do with the powers? You multiply them. If you have a power of a power, you multiply the powers. And I'll explain why in a minute. I'll actually work it out and show you the longhand. So that you can go, oh, all right. So for the first example here, we have 2 cubed squared, right? And the property says if you have a power inside and a power outside the parentheses, you multiply the 2 powers together. So we took 3 times 2 and got 6. So that's using the property. So I'm going to actually write this out by hand and let you see where the property was built out of. So So what does it mean to square something? What does it mean to square something? Not double it, but multiply it by itself how many times? Twice. So what is being taken to the second power? 2 cubed, right? Everybody okay with that? So I have a 2 cubed times a 2 cubed. Now, what does it mean to cube something? Multiply by itself how many times? 3 times. So I have a 2 times 2 times 2 times a 2 times 2 times 2. So if you take a look, how many bases do I have in this statement? What's the base I have in this statement? 2. How many 2's do I have? So I get 2 to the 6th. So this is really what's going on with powers. So instead of writing it out like this all the time, we just use the property and go, oh, 3 times 2 is 6. Done. Everybody okay with that? Yes, no, maybe? Yeah. No, what I want to see is 2 to the 6th equals 2 times 2 is 4, 8, 16, 32, 64. That's your final answer. If it's a number, it has to be evaluated. We're just going over the properties right now, so I haven't gotten there. But I need to see both of those items in order for you to get full points. Yeah, and it'll do it and spit out 64, which is cool. But because I'm also trying to test you on the property, I want you to use both. With variables, it's super easy because you can't type that in. But if you do get a number to a power, I want that to be evaluated. Okay? Everybody all right with that? Yes, no, maybe? So any questions on this property? A to the m, quantity n is a to the m times n. Everybody good? Okay. Next. So let's cook through these real quick. What's 2 to the 2nd, quantity to the 5th? It's just 10. S, no. S sub 10, no. You said this. This is the answer? S to the 10th. I'll buy that one. I drive an S10. That's not an answer. It's a baby truck, yeah. All right. Everybody okay with number 1? All right, number 2. What do you get? 10 to the 6th, which is equal to, and it should be, huh? No. 1 million. So how do you handle 10 to any power? So it's 1, and then the exponent number of zeros, okay? So like 10 to the 3rd is 1,000. It's a 1 followed by 3 zeros because the power is 3. For here, what's the power? 6. So it's a 1 followed by 6 zeros. So that's how you evaluate 10 to any power. Everybody okay with that? Yes, no? Okay, so for 3, what you got? Yeah, there's 2 distinct bases, so we should have 2 bases in our answer. P to the 12th, Q to the 15th. Is there anything else I can do to simplify those? Can I combine a P with a Q? No. Different bases, so I just stop when they're as small as I can get them. All right, any other questions on those, yes or no? All right. They are. The main, to be honest with you, they're easy as long as you know the rules. If you don't know your rules, come quiz time, these get really hard in a hurry because you have to expand everything out and then shrink them back down. Okay, so as long as you know your rules, you're good. So that's what we really need to focus on learning is what to do in what situation. Okay? So if you notice here, where's the power, inside or outside? Outside, and what's inside? Right, and how many bases do we have this time? 2. So just like if you haven't noticed, as we keep working, parentheses continue to play a bigger and bigger role in our calculations. That is still true, okay? As we go on with math, parentheses matter more and more because they differentiate between what is happening to what piece, okay? So the way that I always think of this one is it's like the distributive property, okay? I've got the M outside. I distribute it down onto the A and then down onto the B. So I get A to the M times B to the M. And then once I get rid of that set of parentheses, I'll evaluate each piece as it comes up. So if you look at the example, xy cubed, I get the first base of x to the third and then the second base of y to the third and just get x cubed, y cubed. Everybody all right with that? So I'm going to do this problem here a little bit differently. If I have 3a squared, I'm going to move the 2 onto each base. So I'm going to get 3 squared times a squared. Is everybody okay with that? But what's 3 squared? So you get 9a squared. Okay, is it the same answer as here? Yes, in the same number of steps. So you can do it either way, okay? Or you can use what the definition of squared means, so you have the repeat of what's in the parentheses, and then combine your like terms, or you can just use the property as it's written up above. All right? Everybody okay so far? Yes, no, maybe? Next rule. After we do some practice. So real quick, what's AB quantity to the fourth simplified? A to the fourth, B to the fourth. Make sure you're using the to the. What about the next one? Any questions on that one? The 2 goes onto the 4 and onto the A. So what's 4 squared? 16, right? And then a squared is a squared. Yeah, so the 2 outside has to go into both pieces, so it'll look like this. Like that. Okay, so for the m, right, what's currently written on my m? M cubed, right? And then what's the power outside? 4. So I'm going to put a 4 on the m, and what's the current power on the n? 2, and then I'm going to put the 4 from the outside, right? And then I'm going to use the previous property where I take a power to a power. What do I do with the powers? Multiply. So what's 3 times 4 here? And then for n, what do I get? 8. Is everybody okay with how I'm jumping to that? Okay. Then let me erase this, and you guys just tell me the answer. Not 9. 27, because it's not 3 times 3, but 3 to the third, right? So I'm going to get 3 to the third times x cubed to the third, and what is 3 times 3 times 3? 27. And then what do I do when I take a power to a power? Multiply the power, so it's 3 times 3. So I get 27x to the 9th. Everybody all right? Okay, so tomorrow we're going to finish these up. We've got 3 or 4 more to get through.